So in this session, we'll be seeing the problem 11 in your 10th NCRT book. A concave lens of focal length 15 centimeter forms an image 15 centimeter from the lens. So what is the concave lens? Basically, it is the diverging lens. All right. So this is how you will represent your concave lens, and you have a principal axis. You have an optical center, optic center. And a quick reminder here is always both in the case of your concave and convex lens, you have two focal points. It is because both the lenses are formed by combination of two lenses. All right. So you have two focal points in both your concave and convex lens. F2. And like your mirror, here also you have radius of curvature C1, or you can simply name it as 2F1, because the distance OF1 is equal to CF1, and since it is OF1 is F1, OC1 was equal to 2F1. Likewise here you have center of radius of curvature or 2F2. Alright. Now what is given in the question? Uh, concave lengths of focal length 15 centimeter. So OF1 is 15 centimeter. Distance OF1 is 15 centimeter. So what will be 2F1? Yes, it is 30 centimeter. The center of curvature is 30 centimeter. Forms an image 10 centimeter from the lens. So where is the image formed? 10 centimeter from the lens. So since, and I'm highlighting you, since it is a concave lens, always the image formed is virtual and erect. Only two position of the object's possibility is given in your textbook. One is at infinity, check to the tabular column, and one other one is between infinity and optical center O of the lens. So only two possibilities are there. Since it is virtual, always the image will be on the left hand side. So this you keep it. Real means the image will be on the right hand side. Virtual means it will be on the left hand side. So 10 centimeter from this lens. So 10 centimeter left hand side to the lens. Here is your image formed. A dash, B dash. So where will be the object placed? How far is the object placed from the lens? So let us go into the problem. What is the lens formula? Lens formula is 1 by V minus 1 by U is equal to 1 by F. So what is V? V is image distance. U is object distance. Distance I'm meaning is from the optical center, right? And F is your focal distance, focal length. So this 10 centimeter, right? This 10 centimeter distant from the optical center is your V, image distance. So before applying the formula, one thing you have to keep in mind is about the sign convention. This is similar to your x and y axis. This is your x axis. This side will be positive, your right hand side will be positive and left hand side will be negative. In the y axis, upper direction will be positive and the lower segment will be negative. This is the sign convention you have to follow for an image, object and focal length also. And one more key point to be noted is always the focal length of your concave is negative and focal length of your convex lens is positive. This you have to keep in mind. Always the uh, focal length of concave lens is negative in magnitude. All right. So where is your image placed? This is the image distance V. Where is the image placed? It is placed on the optical center B. This point, see, this is your optical center. It is placed on the left hand side. Look at this diagram. Your optical center is this. So where is the image placed? On my left hand side. So what will be the sign convention for image? It is negative. So minus 1 by 10. Object is what you have going to find. It is given with the formula minus. So where is my object going to get placed? It is also going to be getting placed on the left hand side of the optic center, right? Somewhere here only your object is going to get placed on the principal axis. So this becomes 1 plus 1 by u is equal to, since it is concave lens, my focal length is going to attain negative magnitude, minus 1 by 15. Or you could rewrite it as 1 by u is equal to minus 1 by 15 plus 1 by 10, or 1 by u is equal to, taking LCM for 10 and 15, it is 30. So this is going to be minus 2 plus 3 by 30. 1 by u is equal to 1 by 30, or u is simply 30 centimeters. So where is my object going to get placed? 30 centimeter from the focal point. So this is 25. To F1 is 30 centimeters, or my radius of curvature is at 30 centimeters. So my object is also going to be placed exactly at center of curvature AB. So now we have to draw the ray diagram. So how the ray diagram is? So let me redraw my lens bigger so that I could actually show you the intersection of points better. A bigger lens. Okay. So the light ray parallel to your principal axis is actually diverged. But it tends to pass through this focal point. Yes, it appears to pass through the focal point. The path actually diverges, but if you extend the place from where, see, one more time I will redraw it. I'm sorry. So this is my incident light, and at the optical center it diverges. It is getting scattered. But if you follow the rule given in the book, if your light ray is parallel to the principal axis, then it will pass through the focal point. So if you extend the point from where it actually diverges, it appears to pass through your focal point. And and it is given that if the incident light ray is passing through your optical center, then it gets reflected to through the same point. So this is where my image is going to get formed. The intersection of the 2 points is where my image is going to get formed. Since we are not using any rulers, or since we are not taking any exact measurements here, my image will get slightly modified, but the information given and the diagram we have drawn in the starting is correct. But since we are not having any rulers or scale to measure here, I'm just shifting, you know slightly rearranging my diagram. I had previously drawn on this point. Now it is actually this point. This is 10 centimeter. This is the distance 10 centimeter. All right. So this is the place where your image is formed, A dash, B dash. From A dash, B dash is formed. So how is your object? How is your image here? It is virtual. Virtual means on the left hand side, right? Virtual, erect, and diminished. So the object is also placed at not infinity but at a measurable distance, and here it is exactly at the center of curvature. Thank you.